In this video, I'm going to be solving this integral in two different ways. This integral of square root of 1 minus x over 1 plus x dx. In this first way, I just directly took it from the post that I found it from. It's an algebraic hack that makes the integral easier to solve. And then in the second way is probably the way I would think about it and go about it. It's more tedious and much more involved, but I get the same answer. And again, I'm just more comfortable with those techniques that I've learned and mastered versus this algebraic hack, which is a little more difficult to see unless, of course, if you have experience doing it, then you might be more comfortable doing it. But anyway, let me go over what happens. Okay, so again, we have this integral square root of 1 minus x over 1 plus x dx. Okay, you could multiply by 1 minus x on the top and bottom of the fraction. That's just multiplying by 1, right? So that's totally allowed. When that happens, well, on the top is just 1 minus x squared, and on the bottom is difference of 2 squared, so 1 minus x squared, like that. This is 1 minus x quantity squared, and this is 1 minus x squared, okay? We can use properties of radicals to split it up into two radicals like this, because it's a division, so we can split it up like that, okay? The top, assuming the domain and all that is always positive, then we can square root the square, so the square would go away, so we just have 1 minus x left, okay? Again, this is just assuming there's no problem in the domain and all that, which this person didn't specify, actually, so technically not 100% correct. But anyway, so from here, we can split this up into two fractions and two separate integrals as a result. Okay, this first one is just arc sine. This one, we can do a substitution. So I let u be 1 minus x squared, du is minus 2x dx. So then we get this after the substitution. And then we integrate, it's just the power rule, so we get square root of u, and then we back substitute. Okay, so it's actually a quite simple looking function here. But then, and it's actually quite simple looking derivative, but it's actually kind of hard to get from here to here. You had to know to do this algebraic hack. Again, me personally, I would not have thought to do this. The techniques I've learned it and been teaching for years is like substitution, trig sub, integration by parts, those techniques, partial fraction decomposition, and all those. Okay, those are the ones that I'm thinking of right away. Which ones can I do? And then if none of them really work, then I might do some algebra. Okay, so this is what I did. You can see it's much more tedious. Okay, so back to the original integral. Okay, so we split it up into this by properties of radicals, again, similar to what we did in the other case, okay? Now here, I decided to let u be square root of 1 plus x. I thought maybe I can substitute the bottom and then I could rewrite the top in terms of u as well. We could differentiate from here, but it's a little nicer if I square both sides, so u squared is 1 plus x, and then differentiate from here. You get the exact same thing. 2u du is dx, okay? Versus here, if I differentiate, we'll get 1 over 2 square root of 1 plus x, and then move that square root to the other side, which is u, so then it's the same answer, okay? So I can get this, that's u, and then dx is 2u du, but I need this radical up here, substitute in terms of u as well. So I start from this definition of u, or yeah, from here it's easier, okay? So u squared minus 1 is x, okay? Multiply both sides by negative 1, we get 1 minus u squared is minus x, okay? And then we add 1 on both sides, and then we square root. Okay, so square root of 1 minus x is square root of 2 minus u squared, okay? So I substitute everything in this integral in terms of u now. The u's here would cancel, the 2 I can move out in front, and we have this left. Something squared minus something squared. Trig sub is what I'm thinking right away. So I set up my triangle, okay? And then I substitute everything in this integrand in terms of theta. Okay, by the way, if you're not familiar with how to set up this triangle, I would refer you to my crash course in trig sub video. Okay, I'm not going to go over the details here in the interest of time. Okay, so I need the square root term from the triangle that is cosine, right? So cosine theta times is square root of 2 minus u squared divided by square root 2. So just move the square root 2 to the other side. And then we need du, so I need to get u. So sine theta is u over square root 2. So square root 2 sine theta is u, and then du is square root 2 cosine theta d theta. Substitute everything, I get this. Okay, square root 2 times square root 2, that's just 2. And then that's a constant, so move it out. 2 times 2 is 4. And then we have cosine squared. Oh, this should be very familiar. This is half angle identity. So it's half times 1 plus cosine 2 theta. All right, this half combined to 2. This we can integrate. This is just theta, and this is just half sine 2 theta plus c. Okay, we can use the double angle identity. Sine 2 theta is 2 sine theta cosine theta. So that 2 and this half would cancel, so we just have sine theta cosine theta. And now we start back substituting. What is theta? Well, theta, we can just go from here, is arc sine of u over square root 2. Okay, what's sine theta? U over square root 2. What's cosine theta? Square root of 2 minus u squared over square root 2. Okay? We need it in terms of x, not in u. So we still got to back substitute. What is u in terms of x? U is square root of 1 plus x. Okay? So that's what happened here. That's what happened here. U squared, we also had a definition up here. So that's just 1 plus x. So I directly use that over here. Be careful with parentheses. Okay? Now, this I just combined into one radical. You didn't really have to do that. But here I start simplifying more. 2 minus 1 plus x in parentheses there. It becomes 1 minus x. And then I combine these to 1 minus x squared. Difference of two squares again inside the radical. Okay? You'll notice that this doesn't completely look like this. Did I do it wrong? Does my method not work? So this is what I was thinking right away when I was solving this. So let's check on a graph. Let me pull up my phone. Okay. So this is how the graph looks. The red one is this one right here. The blue one is this one right here. So they're not the same. Or are they? Well, remember, plus c. So I can shift the blue one down, my answer down, by whatever that is. If I remember correctly, it was like 1.5, 1.6, around there. Shift it down, and that's still the plus c. So it is the same answer. It looks kind of different, right? This first term specifically. But there's probably some properties of inverse trig functions that I don't even know that can get it to match this and then lump everything into the plus c. So you can clearly see it's just a shift. So just lump it into the plus c. So it's the same answer. Okay, even though it looks different. So, again, moral of the story or this video is, this is, at least personally for me, it's really hard to think of to do this. Just from my experience and from all the problems I've done, I don't usually do this. Instead, I try the techniques that I keep teaching and keep practicing from doing the problems with my students. Substitution, trig sub. Those are common techniques that you learn, so just stick with those if you're familiar. Obviously, you can see it's quite tedious compared to this one. If you just were able to see the algebra, not as bad, but this one, a lot more steps. Not a whole lot more, but definitely more. But again, if you're comfortable with these techniques, just stick with it. Again, I, as an instructor, and I've been doing calculus for I don't know how many years now, I would personally think to do it like this instead of like this. All right, hopefully this video was helpful. Whether you got stuck with this specific integral or you want some more practice, and of course you should practice with both ways if you're really trying to get better at integrals. And if you got confused of why these two don't match, hopefully my explanation and that graph helps, okay? As usual, please like and subscribe if you found this video interesting or helpful, and hopefully you'll see you in the next video as well. Bye.